Dancing raisins. Carbon dioxide gas dissolved in soft drinks gives them their fizz. You can use carbon dioxide fizz from a soft drink to make raisins dance. Dancing raisins. For this experiment, you will need a can of colorless soda, maybe two, a tall clear glass or plastic cup, and lastly, several raisins. Fresh raisins work the best. Pour the can of soda into the tall glass. Notice the bubbles coming up from the bottom of the glass. The bubbles are carbon dioxide gas released from the liquid. The carbon dioxide gas that is released is what we call fizz. Now, drop 6 or 7 raisins into the glass, only 6 or 7. Watch the raisins for a few seconds. Do you think that they'll sink or float? Keep watching to see what happens in the next several minutes. As you can clearly see, the raisins are sinking to the bottom and floating back to the top.
Raisins are denser than the liquid in the soda, so usually they sink to the bottom of the glass. The carbonated soft drink releases carbon dioxide bubbles. When these bubbles stick to the rough surface of a raisin, the raisin is lifted because of the increase in buoyancy. Buoyancy, the power to float or rise fluid. Relative lightness. When the raisin reaches the surface, the bubbles pop, and the carbon dioxide gas escapes into the air. This causes the raisin to lose buoyancy and sink. This rising and sinking of the raisins continues until most of the carbon dioxide has escaped, and the soda goes flat.
Any object whose density is just slightly greater than the water's has a rough surface to which the gas bubbles can attach should be able to dance in the carbonated water.
Carbonated beverages are prepared by putting the beverage into a can under high pressure of carbon dioxide gas. The high pressure causes the carbon dioxide gas to dissolve into the liquid. When you open a can of soda, the noise you hear is produced by the carbon dioxide gas as it rushes out of the can. When the soda is opened, the decreased pressure allows some of the carbon dioxide gas dissolved into the liquid to escape. This will mix the bubbles in the soft drink. As you can see, the raisins are going up and down. They're sinking and then they're rising. Keep watching for a little while as they sink and float and rise. Now we're going to put some more soda into the bottle and let's see what happens.
What do you think would happen if we replace the raisins with lifesavers? Try it.
Let's try it.
As you can see, there's still a bit of carbonated gas in the soda. So we are adding more just to make sure.
Now let's add some lifesavers.
As you can clearly see, this is just another way to represent baking soda and vinegar that they use to make a volcano. It is the same formula which makes the volcano rise. Do you think anything is going to happen to the lifesavers?
I don't think so.
Why is that? Well, it's because the reason is that it is because the lifesavers are much more dense than the soda, which thus makes them to sink straight to the bottom and not come back up. The raisins are slightly less dense than the soda, which makes them fall down and clearly go back up. Well, that is clearly how raisins dance.
Dancing Raisins. Goodbye. See you next time. Wow, I think I'm gonna drink this phone. Dancing Raisins by Hickhart and Hart.
There is one raisin that is still rising and sinking.